Watch this. One stick, two random breaks. Three pieces. And they do not close. Again, two fresh breaks, three fresh pieces, and again there is a gap. One more, and this time they meet. Nothing is rigged here. Both breakpoints are picked uniformly at random, and most of the time, the pieces refuse to make a triangle. So the question a trading desk hands you is how often they do. One number. Go at it with brute force, and you will be doing casework for 20 minutes. There is a picture that settles it in about 10 seconds. First, what random has to mean here, because that is where this problem hides its teeth. Call the stick 1 unit long. Pick two numbers, x and y, both uniform on that unit, independent of each other, and both chosen before anything gets cut. Then cut at both marks at once. That leaves 3 pieces. From 0 up to the first mark, between the 2 marks, and from the second mark to the far end. Their lengths add up to 1, and we are going to lean on that harder than on anything else. Every position is as likely as every other. No hidden bias, no cutting the longer piece first, no rounding. Hold on to that middle one, because later I am going to change it, and the answer changes with it. Now the guesses. The most common one I hear is a half. It feels like a coin flip. Either they close or they do not, and there is no obvious reason to favor either side. The next most common is a third, usually from somebody half remembering a different problem. And then there is the answer that is technically fine and still loses the room. Set up the integral. 3 triangle inequalities. 6 orderings of the pieces to keep straight. Bounds on each one. A page of algebra. And with luck, the right number at the bottom of it. I want to be fair to that third attempt. It is not wrong. It is doing 3 times the work the question asks for, and it tells the person across the table nothing except that you can grind. What they are watching for is whether you notice that those 3 inequalities are one inequality. Notice where the difficulty actually sat. Not in the geometry. In pinning down what the word random meant. That is the crack a real screen is built to find. 15 years recruiting in finance, on the side of the table where the decision gets made, and it is the same crack nearly every time. So I put the fix in one place. The Quant interview playbook. 281 worked exercises, 4 tracks, and mock interviews with the scoring written in the margin. Link is in the description. Now, that one inequality. 3 links make a triangle when each one is shorter than the other 2 put together. That is 3 conditions, and they look like 3 separate things to check. But our 3 pieces add up to 1. So take any piece and call its length p. The other 2 together come to 1 minus p. The condition that p is shorter than them is p less than 1 minus p, which is p less than a half. That is the whole reformulation. Not 3 inequalities, 1 sentence. No piece may be longer than half the stick. And once it is said out loud, the picture is obvious. If one piece is longer than half, the other 2 together are shorter than it, and they cannot reach across. You get a flat, broken hinge instead of a triangle. Notice we have not touched probability yet. This is algebra on a perimeter. The probability starts now. The trick is to stop looking at the stick. The experiment is really 2 numbers, x and y, each somewhere between 0 and 1. So one run of the experiment is 1 point in a square. Every point of that square is one way the stick could break. And because both numbers are uniform and independent, the chance of landing in a region is just the area of that region. Probability has become area. Draw the diagonal where x equals y. Above it, the second mark is further along than the first. Below it, the other way round. Take the upper half for now. There, the 3 pieces are x, then y minus x, then 1 minus y. 3 conditions, and each one is a straight line. First piece under a half puts us left of x equals a half. Last piece under a half puts us above y equals a half. And the middle piece, y minus x under a half, puts us below the diagonal shifted up by a half. 3 half-planes. What survives all 3 is one small triangle. Look at what survived. A right triangle with corners at 0.5, a half and a half, and a half and 1. Both legs are a half, so its area is a half times a half, halved. 1/8. And there is a mirror image of it under the diagonal, for the breaks that arrived in the other order, with exactly the same area. 1/8 plus 1/8. A quarter. The whole square has area 1, so that fraction is the probability as it stands. 2 random breaks, and the pieces make a triangle a quarter of the time. Not a half, not a third. And look at what that took. 1 reformulation, 1 square, 2 little triangles. Not a single integral. Second root, in case you do not trust areas. Say the first break lands at x, somewhere in the left half of the stick. Where does the second break have to land? The right-hand piece has to come in under a half, so the second break has to be past the middle. And the piece between the marks has to come in under a half too, so it cannot land further than a half beyond x. That is a window, and its width is exactly x. So given a first break at x, the chance is x itself. Break at 1/10 of the way along, and you are sitting at 10%. Break nearer the middle, and you climb towards 50. Average that across the stick, and a quarter falls out again, from a completely different direction. And look at the ceiling on that curve. Nothing on it ever reaches a half. The nearer your first break sits to the middle, the better your odds get, climbing towards 50% without ever arriving. Quarter probably still feels too low, and there's a good reason for that. Break the stick and look only at the longest of the 3 pieces. On average, it takes 11/18 of the whole thing. Call it 61%. Your budget was 50, so a typical break is already over budget before you have even looked at the other 2 pieces. Meanwhile, the average shortest piece is 1/9, 11%. A splinter. That is the real shape of this experiment. Not 3 comparable pieces, 1 long one, 1 middling one, and a splinter. Triangles are rare because lopsided cuts are normal. Now the part I actually like. Bend the stick round into a loop and glue the ends together. 3 pieces on a line become 3 arcs on a circle, cut by 3 points. And here's the thing. Breaking a stick at 2 random points gives you the same 3 lengths as dropping 3 random points on a circle of the same length around. Rotating the circle changes nothing, so one of those 3 points may as well be the join. Now translate the failure condition. A piece longer than half the loop means every point sits inside 1/2 of the circle. And that is easy to count. Pick one of the points and ask for the other 2 to land in the half circle that starts there. That is a half times a half, a quarter. Any of the 3 points could be the one at the start, and no 2 of them can be at the start at once, so the 3 cases never overlap. 3/4. Failure 3/4 of the time, success a quarter, which is our answer arriving for the 3rd time. Except now, every other number of pieces comes along with it. Failure is n/2 to the n minus 1. 4 pieces gives a half. 5 gives 11/16. With 10 pieces, you are up around 98%. 3 pieces is the hardest case there is. One more thing. And this is the part that decides interviews. Same words, different experiment. Break the stick once at random. Then break whichever piece came out longer at a random point along that piece. 3 pieces again, and every word of the original question still applies to them. The answer is no longer a quarter. It is twice the natural log of 2 minus 1, about 39%. Better odds, and it makes sense. You never waste a cut on the short side, so you are less likely to leave one piece hogging more than half. Nothing about the geometry moved. The triangle condition is the same condition it always was. What changed was the phrase, "at random," and that phrase was quietly carrying the entire question. So when an interviewer says, "at random," the first move is not to reach for a pen. It is to ask, which random? So what were they testing? Not whether you can integrate, whether you would spot that 3 inequalities were 1 inequality, and that a question about a stick was a question about a square, and whether you would ask what random meant before you started computing anything. 3 ways strong candidates still lose this one. They get the number out and never say why the model was the question. They know the standard books cold and then meet a shape that was never in them, or the clock runs out on the timed round with the right method half written. None of that is a brains problem. It is the wrong shape of preparation. I have coached hundreds of people through this pipeline, and for some of them, it ended with the job they were aiming at, north of $500,000 a year. The playbook is that other shape, mental math at filter speed, probability written as moves instead of formulas, the brain teaser archetypes, then your own track, whether that is trading, development, hardware, or research, with annotated mocks throughout. Link is in the description. Get it before your next batch of applications goes out. And here is the one to sit with. If a quarter surprised you, what was your intuition quietly assuming about the longest piece?